Crypto exchanges are one of the crucial sources of liquidity for any cryptocurrency. One of the foundational ideas of Bitcoin and other cryptocurrencies is decentralization. However, in order to trade these crypto assets, people still had to go to centralized exchanges. Decentralized exchanges, or DEXs for short, emerged in the recent years as a reliable alternative to centralized exchanges. They also present a unique opportunity for us to rethink the design of an exchange from scratch based on first principles. In this video, we'll look at the three main models for building a DEX: the order book model, the automated market making model, and the Dutch auction model. We'll also look at the advantages and disadvantages of each of these models and a quick look at DEX aggregators. I'm very passionate about innovations in blockchain technologies, and as such, a lot of time and love goes into making these videos. So, if you find this helpful, hit that like button so that more people can discover my videos. Now, let's talk about exchanges. Before we start talking about DEXs, let's quickly recap how a centralized exchange works, because these are the precursors to DEXs, and also a journey tells a more cogent story than just the destination. Almost all centralized exchanges work on the order book model. In this, users can place two types of orders: a limit order and a market order. A limit order allows traders to buy or sell an asset at a specified price. A buy order is called a bid and a sell order is called an ask. The order book is sorted such that the highest bid and the lowest ask are at the top of these lists. The difference between these two is called the spread. A market order is simply an order to buy or sell an asset at the best available price on the order book. Markets with high liquidity have smaller spreads since the demand and supply at each level is high. Tight spreads are desirable in any market because they imply efficient price discovery. And that's where market makers come in. They provide more liquidity into the market by taking on risk and reducing the spread. They make a profit when the short-term market moves in the direction they predicted. Market makers are crucial to efficient functioning of an order book model. In centralized exchanges, assets have to be deposited into the exchange before trading. The order book and all trades are executed by a central server. This makes centralized exchanges a huge target for hacks, and there were many of them in the past. And also, the ever-present risk of running away with users' funds. On top of all this, centralized exchanges often require KYC verifications and also inherit all the drawbacks of an order book model that we will discuss in a bit. DEXs using the order book model. Examples of order book DEXs include DYDX, 0x, and Binance DEX, etc. Order books can be stored either on-chain or off-chain. Off-chain order books need additional infrastructure to store and maintain the order books. Relayers in 0x are a good example of such infrastructure. 0x provides a framework for building different DEXs and maintaining order books of these DEXs. Users still maintain custody of their assets at all times. All trades are settled on the Ethereum blockchain. Given that the Ethereum network is currently limited to 15 transactions per second, storing order books off-chain can help with scalability. DEXs with on-chain order books maintain their order books on the blockchain and thus have the benefit of censorship resistance. On the flip side, users will have to create blockchain transactions and pay for gas in order to post limit orders or cancel an existing order. Vitex is a good example here. Vitex runs on its own blockchain called Vite, which supports high performance, low latency, and zero transaction fees. This makes sense given the low throughput of the Ethereum blockchain. There are also layer 2 solutions on Ethereum, such as Loopring Exchange, that uses ZK rollups to achieve similar results on the Ethereum blockchain in a scalable manner. The solution space is vast and exciting. The order book models also employ different techniques for order matching and trade execution. We shall look at some of these using examples as we go through the pros and cons of the order book model. Pros. Good for liquid markets. When there is a lot of trading volume and market makers maintaining tight spreads, the order book model is great for finding the true market price and also filling large orders without much slippage. This is the reason why high volume centralized exchanges like Binance, Coinbase, and traditional venues like the New York Stock Exchange use the order book model. They also have their share of downsides. Bad for illiquid markets. An order can be fulfilled only if a bid price matches an ask price or vice versa. This means you won't be able to trade in these markets if your highest bid is still lower than the lowest ask. With illiquid markets, order book exchanges result in large spreads and variable prices. Front running. Front running is a process in which someone who has knowledge of a large future buy order buys up that asset before the original order and sells it immediately to make a profit. In centralized exchanges, only the exchange has such information and front running is banned by law. However, this can be a serious problem on DEXs that use on-chain order books because to place an order, you would need to submit a transaction to the blockchain and miners can see all transactions before they're included in the block. If the order is large enough, miners could create their own buy and sell orders in this block and place them before your transaction, thus earning a risk-free return. There are several novel solutions to prevent front running in order book DEXs. The injective protocol uses verifiable delay functions to timestamp orders so miners can't front run users. Binance DEX uses fast matching and periodic auction matching to make front running impractical. Market manipulation. The order book model is by design very susceptible to market manipulation. The order book gives hints about the short-term price direction of an asset. For example, a large number of buy orders could indicate rising price due to increased demand for that asset. These signals are just clues that can change any moment. This opens up possibilities for different types of market manipulations, such as spoofing, wash trading, and pumps and dumps. All these tactics could create an unstable market environment for all participants. Traditional venues like the New York Stock Exchange have strict regulations to punish such unethical behavior. However, real-world laws do not necessarily apply so easily on DEXs and to its participants. DEXs using the automated market making model. The AMM model fixes some of the shortcomings of the order books. AMMs as a concept has been known among academic game theory researchers for over a decade now. Yet, AMM DEXs are the first known public applications of this model built at scale. AMMs do not contain any order books. Instead, they pool liquidity from different users and anyone can buy or sell an asset from the liquidity pool. They use deterministic algorithms to code the price of an asset for any given trade. The algorithm used to determine the price can be different for each AMM. Uniswap is the most popular DEX by daily volume. It's an AMM that uses the constant product market maker model. On Uniswap, liquidity pools are maintained for each trading pair. Anyone can be a liquidity provider by depositing pairs of tokens to a pool. In return, they earn fees from all trading activity in that pool. For example, in a ETH DAI pool, the price of ETH for a given trade is determined by the constant product equation. The goal is to maintain the product constant before and after each trade. Bancor is another DEX that uses a similar strategy but a slightly more complex equation to determine the price of assets for each trade. Pros of AMMs. AMM DEXs are good for illiquid markets. As long as there is liquidity pool for a given asset, you will be able to trade that asset regardless of the order size. This is great for assets with a low market cap or when the liquidity is fragmented across different markets. Since all trades are made directly with a pool, there is no need for order matching. Of course, it's not a free lunch. There are also downsides to this model, such as high slippage for large orders. The price you pay for an asset can change significantly if the size of your order is comparable to the size of the liquidity pool. For example, if you are buying 50% of ETH in a ETH DAI pool, the average price per ETH can double during your trade. A slippage rate of 100% would be outrageous in the order book model. To keep slippage under 1%, the liquidity pool would need to be 100 times greater than the size of the order. AMM exchanges are great for getting the best average price for illiquid tokens only when the order size is a small percentage of the liquidity pool. This is one of the reasons why large institutional traders placing orders worth billions of dollars per day don't use AMMs. Risks for liquidity providers. When providing liquidity to a pool, you face the risk of impermanent loss. Impermanent loss happens when the current price of your deposited assets changes compared to their price at the time of depositing. The bigger this change, the more you are exposed to impermanent loss. The loss here refers to less dollar value at the time of withdrawal than at the time of deposit. I'll cover impermanent loss in more detail in a future video, but for now, it is sufficient to know that providing liquidity to a pool is not risk-free. DEXs using the Dutch auction model. The Dutch auction model works on the principle of the Dutch auction. In a Dutch auction, the price of an asset starts high and it is lowered until it gets a matching bid. The first matching bid results in a sale. There are different variations in the model to determine when a sale occurs and at what price. When Google launched its public offering, it relied on a Dutch auction to earn a fair price. DutchX is a popular DEX built on this model. On DutchX, there are two phases in the trading process. In the first phase, which is before the auction starts, sellers deposit their tokens to place sell orders. If the deposits pass over 1000 USD worth of tokens, then the auction begins, with the price per token set at double the closing price of the last auction. Now the second phase begins. The price starts falling according to a decreasing function, and buyers can actively place their bids at different price levels. When the entire volume is bid upon, the auction ends and the closing price of the auction is determined. All buyers with the bids before auction closes will receive their tokens at the same closing price. And similarly, sellers will receive their proceeds according to the closing price. Advantages of this model include good price discovery for illiquid tokens. The Dutch auction process is better at determining the fair market value of an illiquid token than other models. This is why Dutch auctions are commonly used by platforms like Decentraland and CryptoKitties to allow for price discovery of new or rare NFTs. Reduces front running. Since all buy orders in an auction are executed at the same closing price, this prevents miners from front running individual trades. One of the biggest downsides of this model is slow trading time. Trades are not executed until the auction is complete, which can take up to several hours. Since trades are not instantaneous, Dutch auction models are impractical to do faster trades like market orders in the order book model or swaps in the AMM model. To sum up, order book exchanges are great for highly liquid markets. AMMs are good for illiquid markets, and Dutch auctions are perfect for price discovery of new and rare items like NFTs. DEX aggregators. There are many implementations within each DEX model. This gives users a lot of choice and developers a chance to innovate on different mechanisms. However, this approach also results in liquidity getting fragmented across different platforms. This lack of concentrated liquidity on one platform can result in high slippage for large trades. DEX aggregators aim to fix this exact problem. 1inch Exchange is a popular DEX aggregator. The 1inch platform aggregates liquidity from different DEXs. It does this by splitting orders between many other DEXs and private liquidity providers to find the best possible exchange rate for each trade. We covered a lot of concepts and protocols today. To learn more about these topics, check out the links in the description. And if you like to see a video about a specific DEX or concept, Let me know in the comment section. That is it, folks. And don't forget to hit those like and subscribe button. Thanks for your time. My name is Praveen, and I'll see you again soon.